So, welcome to our channel Electronics on Wheel and thank you for your support. Please like, subscribe, and comment if you like the content of this video. So, let's start with our next topic, that is our 48-volt battery system. As you can see, so one of our team member from EOW has already created the video on 48-volt architecture where he has discussed about 48-volt architecture from the scratch, why we use the 48-volt architecture and what is the reason behind using the BSG and ISG and what are the merits and demerits. So when you are using 48-volt architecture, then vehicle comes under the mild hybrid electric vehicle, that is our MHEV. So this is nothing but mild hybrid electric vehicle. So today we have taken one practical example. As you can see that we are going to discuss about Hyundai Tucson, where they have used the 48-volt architecture. So here in this video we will try to understand the operation of 48-volt architecture and component specification. So let's get started. So when MHEV uses, so basically two things it uses. One is your engine and other one is your MHSG. MHSG is specific to this Hyundai Tucson. So what does it mean? That mild hybrid starter generator. So the concept of 48-volt architecture is itself is that when you are using one particular alternator in a terms of starter and generator, that particular motor is working as a starter and generator, then it means that your vehicle is coming under the mild hybrid or micro hybrid as well. So that is different, but micro hybrid, but as of now we will understand the mild hybrid. Okay, so we are talking about the 48-volt. If we were using the 12-volt, then it would be a different terminology for that. So mild hybrid starter generator actually not only support to the engine, as you can see here, this is your MHFG. Basically it supports the engine during the acceleration, and second thing what it does, it also generate the electricity during the regenerative braking. So when you are giving the braking, okay, you are putting the brakes, then this particular MHSG, I will say starter and generator, this starter generator will act as a generator. Okay, so you might have the basic knowledge about 48-volt architecture. That's why I was saying, if you do not have the basic knowledge of 48-volt architecture, you can see the previous video where one of our colleague has discussed about the how this BSG, belt starter generator, ISG, integrated starter generator works, what are the architecture P0, P1, P2, P3. So these things are explained there in detail, so you can understand the basic things there. But if you know the basic things, then you can continue watching this video, then you can understand what we are talking about here. So we will understand this function. So before going to the function of this particular function, 48-volt architecture, then we will go to the location of these components. So if, as you can see here, so we have the component, so what are the components, let me tell you. This is our 48-volt battery. Then this is our LDC is nothing but the low voltage DC converter. We will discuss about this. MHSG is nothing but mild hybrid starter generator. So other OEM might be using some different terminology for the same thing. Okay, but the concept or the function will remain same. Then here starter, we will understand here also why they have given the starter, that they are using a 12-volt starter also. So you might be having this question in your mind, that when you are already having the MHSG which is going to work as a starter and generator, then why this extra starter is here. Then this is our your transmission. So this is your transmission and this is your regenerative braking. So first we will see the location of these components, and then we will start asking the question why they have given the starter 12-volt conventional starter, and then we will go further deeper. So as you know that this would be your 48-volt lithium ion battery, but as you can see this particular location of this lithium ion battery or 48-volt system would be on the luggage compartment, where you can find out this particular DC-DC converter and 48-volt lithium ion battery. Then this would be your power cable, and power cable is going to the front of the ISG. So in this ICE, this is internal combustion engine, and this particular component is mild hybrid starter generator plus inverter. So this is used, inverter is used to convert your AC to DC, then only your battery will be charged, right? And this is your 12-volt battery, that is the conventional battery where you are using in every other vehicle, and what are all the functions, like all the accessory functions are driven by this battery, not the direct with the 48-volt battery. So we will see also that 48-volt battery directly connected to some of the functions like AC and HVAC and other function, but not for the each and every other functions. So mostly 12-volt battery would be used, but here also we will see what are the function directly connected to this 48-volt battery as well. So as you can see this particular mild hybrid starter generator, as I shown you here, so this would be connected through a belt. Okay, this belt will connect through the crankshaft of the internal combustion engine to this particular starter generator engine. I hope till here you understand the architecture, what is the component location and what are the functions. So we will start with the modes and operation of the this particular 48-volt battery system. So the first question which I told you, so you will be having that why we having the starter generator, right? Sorry, starter motor, that is your starter motor apart from this MHSG, because you have already MHSG, why we are having the starter 12-volt starter motor. Okay, this is your conventional starter motor. So this is, there is a one reason. Okay, it depends on the OEM whether they are going to keep this conventional starter motor even you are having the 48-volt battery system. But what is the reason behind the Hyundai Tucson they are using? That during the initial starting operation, what will happen, that your engine oil might be very cold, like temperature minus 10 degree, minus 20 degree. Okay, so this type of temperature when you have, then your engine require higher torque. Okay, so it require, this particular engine requires the high torque. So when you high torque is required, then this particular MHSG is not sufficient to give the high torque. So to assist that particular operation during the engine start, this our conventional starter motor will help to give the extra torque. You got the point? So this is the one reason. There is a other another one reason also, but I would like to know from you people that please comment in the comment box that what might be the second reason to give the 12-volt starter conventional starter motor even you are having the MHSD. So let's start with the first engine start mode. So what will happen when you are starting your engine, then your starter motor, conventional starter motor will help this starting your engine, the ICE engine, and this is your mechanical path. Then we will go to the MHEV mode. What is this MHEV mode? So in this mode, what it will do, MHSG, this MHSG will assist the combustion engine, this ICE engine, during the acceleration, or you can say takeoff. By how it will support, or how it will help, by giving the torque and power to your engine or to your transmission, so that your engine will not have the more load on that. You got the point? So if you have the extra power, right, one power you have from the ICE engine, and second power you will be having from the MHSG, which is supporting your engine during the acceleration, then engine will have the less load. If engine is having the less load, then what will happen, the efficiency will increase. And that is why your mileage of mild hybrid systems always greater than the without hybrid vehicles. You might have seen that it is mild hybrid with mild hybrid system, your vehicle is giving the good mileage. That is the one reason, because your engine is having the less load when your MHSG is supporting your vehicle. So what it will do, second thing, apart from this acceleration, when you are stopping your vehicle during the traffic off, so to restart the engine, this MHSG, this starter generator will help. It will be very quick, faster, and it will be very smoother. So during that starting function, how it will take the energy, it will take the energy from 48 volt. So if you are using the MHSG for the starting your or restarting your engine during the stop start, you might have heard this function, stop start. So during this stop start or start stop function, what will happen, that when you are having the traffic light and you are having your vehicle speed lesser than 20 km per hour, then your combustion will engine will be off, and whenever it is required, then this MHSG will start your engine immediately, you will not even notice when your engine is started. So this is the advantage of MHSG, and MHSG will take the power from the 48 volt battery during this operation. Okay, so during the we have discuss about the starting condition, we have discussed about the acceleration condition, or on start on and off condition. Then we have discussed uh, about the restarting or this acceleration, right? Then suppose your vehicle is having the constant speed, right? So in that condition, what it will act, MHSG. So MHSG is either at ideal state or act as a generator charging the 48 volt battery depending on the battery state of charge. Okay, so suppose your 48 volt battery is already charged, then this 48 volt battery will be charging your 12 volt battery. Okay, so your MHSG is let me erase one time. So at constant speed, what it will do, uh, so first thing, if suppose your 48 volt battery is discharged, then it will charge this battery. If suppose it is charged, right, then it will not do anything, it will be in idle condition only. That is the function. Then we will go to the next thing, that engine start during the ISG mode, which is already I have discussed. So if you see that 48 volt battery will give the power to MHSG, then MHSG will support the engine, and if it will support the engine, then what will happen, that your efficiency of the engine will increase, and because the load on the ICE engine is reduced. So during the acceleration, MHSG supports the combustion engine with compensatory 4 to 12 kilowatt of power, and depending on the battery system of the charge and degree of the accelerator input from the driver. So once the required speed is reached, then MSG shift to neutral mode and delivering no power. So as I already told you, that it depends when you are giving the acceleration and it reached to the certain speed, then MHSG will not do anything, it will become in a neutral state. Second thing, second function, what it will do, it will charge the 48 volt battery, but it also depends on the battery condition. If it is discharged, then only it will charge the battery, otherwise it will not charge. Then we have the third function, that is regenerative braking. So when driver is pressing the brake, then your starter generator, as it names, it will become act as a generator. Okay, so first it was assisting the vehicle, now it will generate the vehicle, and during the generation it will charge your 48 volt battery. So when act as a generator with maximum recuperative output 10 to 12 kilowatt, generator converts the kinetic energy into the electricity and feeds back into the 48 volt battery. So this is the function of MHSG during the acceleration, during the regenerative braking, and during the ISG mode. So this is the same thing which I told you, that if suppose your combustion engine will remain switch on and clutch kept closed to be able to transfer the power from the vehicle over the transmission and engine to MHFG. This is only the regeneration or braking condition only. So during this only MHSG will power your 48-volt battery during the regenerative braking condition only. So we will try to understand by this graph as well. So these are the different driving conditions. This is the 48-volt battery SOC, state of charge condition, and these are the mode. So first state mode is engine start. So your driving, your car will be started. Then suppose you are in the condition of the uphill or takeoff condition or acceleration condition. Then what will happen? Your 48-volt battery SOC, state of charge, will be in the discharge condition. Why? Because your starter generator will take the power from the 48-volt battery and it will assist your vehicle during the acceleration. I hope you understand this function. Then third thing is normal driving. So during the normal driving, what will happen? As I told you, that MHSG first will check that 48-volt battery is charged or discharged. If it is discharged, then this 48-volt battery continuously will be charging your 12-volt battery. Okay, so this would be in that condition also. 48-volt battery SOC will remain discharge condition. Okay, then during the deacceleration or regenerative braking, that is the mode of MHSG. So what it will happen, as I told you, that during the this regenerative braking, this starter generator will act as a generator, and when it will act as a generator, then your 48-volt battery would be charging. Okay, you understand, I hope, this function. Then you have the stop, then there is no point, that idle stop. And during this when you have the traffic start stop function, during that your engine will be stop, but your MHSG will support during the restarting your vehicle. That is the start stop function. So as here you can see that when coasting at low speed, the start stop function already activates at 30 km per hour. Under the deacceleration between 30 and 0 km, with clutch disengaged, the engine is switched off completely. Okay, if engine is switched off and you want to give the accelerator, then immediately your starter generator will start your engine. That is the function of start stop function. I hope you understand. Then we will see the condition, the component location. So this is how it looks in the luggage compartment. So this particular thing is your 48-volt battery, and this is your mild hybrid starter generator. These are the power cable. These are the power cable. So let me go into the detail of these components. So what it has: 48-volt battery assembly. So 48-volt battery assembly, this is the first thing. This is your first thing. Then what else? The second thing is your power relay assembly. This would be here. Main fuse will be also here. Then main relay will be also here. This main fuse, main relay would be the this part. Then you have this particular thing. This is nothing but your 48-volt battery module. Then 6 and 6, if you see, that is your BMS, that is nothing but the battery management system. And LDC is nothing but DC-DC converter. So low voltage DC-DC converter. So what it does basically, 48-volt to 12-volt, because you have to charge your 12-volt battery, that is conventional battery. And if you see the seventh one, that is for the cooling fan. This is for the cooling management or thermal management of this particular battery pack. So I hope you understand the function of this 48-volt battery system, how it is working, how many components are there. If you want to see the specification of this thing, that I can show you. So you will be having this in this pack 12 cells, one module. So how many? 12 into 3.75. One cell will be having 3.75. So rated voltage will come around 45. And normal nominal capacity would be 9.8. Okay, so this is 45 volt. So anyone can comment on that, that this is 45 volt, but we are calling 48 volt battery system. What is the reason of this? Then coming to the main fuse. So main fuse specification, the voltage would be the 70 and fuse rated current would be 300 amps. Then main relay, that rated current would be for main relay would be 100 amps. Then low voltage DC DC converter, that is our LDC, which is going to convert your 48 volt to 12 volt, and its input voltage would be in the range of 24 to 54. Output voltage would be 12 to 15.5 to 15.1. Power output would be that 2.3 kilowatt. Then we have your charging battery, that is the conventional battery. You will be having 60 to 48 ah battery, and this is the model type in this particular condition. Then cold cranking ampere. So this is the cold cranking ampere given based on the in the condition where you have the temperature below minus 18 degrees centigrade to minus 20 degrees centigrade. Then what is the ampere this particular battery is providing? Then reserve capacity 92. Then specific gravity, that is 1.28. So this is the actual parameter or in the battery. If you see in any battery, by this battery only we can find out that what is the actual voltage of this particular battery. So specific gravity of any battery if is 1.28, then it means that is 12 volt. Then starting system, if you see the starting system, your rated voltage is 12 volt and 1.3 kilowatt. This starter motor which is I was talking about, that is the conventional starter motor, and number of pinion teeth would be 12. And if you see the current ampere, that would be 100 amps and 3400 rpm it will be going to produce. If you need some more detail of the circuit of this 48 volt battery system, you please comment in the comment box. I will give in the detail in the next video. So thank you for your time, thank you for your support. Please like, comment, subscribe if you like the content of this video. Thank you.